All right, now I shall explain L'Hopital's rule with the use of an example. And what is this all about? Well, let's say that we want to evaluate a limit and we come across this interesting scenario here. Let me plug in 0 for x and see what happens. If I were to do that, I would end up with sine of 0 over 0. Sine of 0 is 0, so we end up with 0 over 0. And that won't help us in actually evaluating this limit. So, and why not? Because this is an indeterminate form, so no cigar. We can't do this to evaluate it. But L'Hopital's rule actually offers us with a tool, a way of actually figuring this out. And how does that work? Well, so let's say that we do come across this indeterminate form, 0 divided by 0, or also something else that would work is plus or minus infinity, or positive or negative infinity over positive or negative infinity. That's another indeterminate form for which L'Hopital's rule would work. And in this case, in case this happens, what we can do is actually take the derivative of the function f of x and take the derivative of the function g of x, the one on the bottom, and evaluate the limit that way. Provided, of course, something very important, that both f of x and g of x are actually differentiable in an interval where a is found. Okay, so that's very important. So let's do that. So let's evaluate this limit using L'Hopital's rule. So I will just actually take the derivative of sine of x, and I get cos of x. That is the cosine of x is the derivative of sine of x. And the derivative of x is just 1. Now, something very important to note, a few students at the beginning, they're tempted to actually do the quotient rule. But we're actually not taking the derivative of the whole thing. So careful with that. We're actually just taking the derivative of the top function and dividing it by the derivative of the bottom function. So keep that in mind. And now we can actually evaluate the limit really quickly by plugging in the 0 for x. So we get cos, did I say 0? Plug in the 0 for x? I hope I did. I can't remember right now. It's been a long day, trust me. So I just plug in the 0 for x, and cos of 0 is actually 1, and that's it. The limit is evaluated, and of course we only know this really because of L'Hopital's rule. That's fantastic. So now let me just use another quick example here to illustrate L'Hopital's rule again in a different way. So let's say that I want to evaluate the limit as x approaches 0 for e to the power of x minus 1 over 3x. So let's check out and see if this would be another indeterminate form, like the ones we have here. So if I were to plug in the 0 for x, I would get e to the 0 minus 1 over 3 times 0. E to the 0 is 1, minus 1 is 0. Down below I have 3 times 0, which is 0, divided by 0. Yes, so we do have an indeterminate form, so we can use L'Hopital's rule. How are we going to do that? We are going to take the derivative of the function in the numerator, and the derivative of e to the x is just e to the x. The derivative of 1, well, that's just a constant, so that's just 0, so we can just disregard it, divided by the derivative of 3x, which is just 3. Now, can I plug in the 0? Yes, I can. E to the 0 divided by 3, e to the 0 is just 1. So 1/3 is the limit. So the limit as x approaches 0 of e to the x minus 1 over 3x is just 1/3. That's it. Hopefully made great sense to you. If not, please check out more videos, and good luck.